We're really happy and excited today. We're having a visitor in our school. His name is Mr. Livingston. He's a science teacher, and he's going to help us, guys, to the mystery of science. I would say it's introduction to science, and further ado, I just want to pass the word to Ms. Carol King.
Good morning. Mr. Livingston is a former teacher at Norland Middle School, and at Norland Middle School. I know they are truly missing him now because he is one of the best scientists I know. He is one of the best teachers I know, extremely knowledgeable. Anytime you need him, he's available, persist in every way that he can. I enjoyed going to his class as I visit his class. His class will always be the last class I go to visit because it was so interesting. He kept a lot of activities there extremely interesting. And one little story I just have to explain to you all. He had 40 kids in a classroom, and 40 is a lot of kids. And we had to balance his class. And when we went to ask the kids who would like to leave his class, no hands went up. He accepted 40 kids in his class. He brings humor into his class, and they enjoy being in this class, and I enjoyed visiting and observing his class in action. So without further ado, I bring to you Mr. Alfonso Livingston.
Today might be sort of like an empty day because some of the information that I need to share with you in order to get you there for your science class. And the last part we're going to utilize is going to be the scientific method. We'll have a short video here shortly, but in order to get you into the concept and understanding of science, we have to understand what science is. I used to tell students that science was the most important class that they could take. Because the only reason that you take math is so you can calculate in science. And the only reason that you take language arts or writing is so that you can write about whatever you discover in science. So everything, if you take history, is so you can find out where you have traveled as you were doing science. So you get the idea how I feel about science. Now, in order to incorporate this science into your daily learning, there are certain things that you have to have in order to do science. And so these certain things that you have to have, we call them science skills. And the one science skill is going to be is observation. Everything that you have learned is because you had an opportunity to look at it and see it and touch it and discover it. So we call that one science skill is going to be observation. And then another thing that we do for science skill is that we hypothesize. You'll learn more about that here shortly. Okay, we hypothesize. We come up with an idea, a testable idea that we can use to find out about the world around us. And also another science skill that we utilize is going to be that we predict things. We predict things. And when we predict things, after we predict them, we kind of have an idea as to what is going to take place. Another science skill that we use is infer. Now, just in case you are not familiar with the word infer, an inference is an explanation of an observation. Now, I'm gonna get some activity in right now. Can anybody tell me, I was walking this morning and I was outside early this morning and the sidewalk was wet. Can anybody here tell me how the sidewalk got wet? How it got wet? It was raining. That's one way that the sidewalk could have gotten wet. Anybody else got an idea? What? Somebody could have been washing the car. Say again? So water fell? Yes, and water could have fallen, or the sidewalk could have gotten wet. What you got for me? Somebody could have poured water on the sidewalk. And so any kind of way, all we doing is explaining our option, which is an inference. I like it when somebody told me one time that the way the sidewalk got wet was the dog urinated on it. But whatever your inference is, that's explaining an observation because you were not there. And then another skill that we utilize is we like to measure stuff. We like to measure stuff. You spend a lot of time measuring, because that's what scientists do. We measure things because we want to know. We're going to talk a little bit more about measuring in a few minutes, because it's like 6 things that we measure. We'll talk about that shortly. And then we also like to, I'm going to erase this, so we'll come back to it. We also like to classify stuff. We classify. And after we classify, we put it into groups. We put it into groups, and we got different classifications for animals. We have different classifications for plants. We got different classifications for cars. We just like to put things in the group so they can simplify and pass that information on to us. And then after we classify some stuff, sometimes we like to analyze it. Now, this is a fun part. I'll make sure I spell this right. I put it on the board one time, and they said, Mr. Livingston, you spell that wrong. I say, so is there something wrong with spelling something wrong? They said, yes. So later on, we had a paper, and they had some words spelled wrong. I marked it wrong. They're talking about, it was just one letter. I said, but you told me it was wrong to spell stuff wrong. We all got to apply by the same rules. And the last thing that we're going to do, we compare stuff. And last but not least, we interpret what we have observed, measured, and classified. We interpret it. Are there any questions about the science skills that you need to develop in order to be an effective science student? Any questions? Okay. Now, let's look at, we got a hand up. Yes, ma'am. We haven't gotten it. We haven't gotten it yet. I'm gonna get it. See, in order to get to the steps of the scientific method, we're gonna take these skills and then we're gonna utilize them. And at the end of this presentation, you will be about as familiar with the scientific method as I am. Any other questions? Any other questions? Okay. Let's erase the board a minute. Now, out of all these science skills that I have shared with you, the greatest science skill that a scientist can have is going to be this one: observation. That's how, through observation, that is how I would say 99% of your learning has taken place through observation. And now, why do I say that? It's how do we observe things? We observe things. How do we observe them? We observe them. We got 5 different ways that we observe things. 5 different ways that we observe things.
Your eyes.
This little word right here. Senses. That's the 5 ways. That's the 5 ways that we observe things through our what? Senses. Now, what are 5 senses? I know everybody knows the 5 senses. Help me out.
Your hand.
No, your hand is not a sense. Your hand is not a sense. Okay, smell. Smell is a sense. What's another sense?
Your eyes.
Huh?
Your eyes.
We're going to say eyes, we're going to say sight. What else? Hearing. I hear somebody say taste, and I hear somebody say touch. Taste and touch. These are the 5 ways that you observe things. What do you hear? What do you hear? Sound. That's it. You hear sound. You hear sound. And it's through sounds, observational through sound, we can pick up a lot of information, changes in our environment. Okay? Now, we hear sound. What do we smell?
Different things.
What do we smell?
Different.
What do we smell? It has, it, what do they give us? What do they give off? Huh? They give off odors. That's what we smell. We smell odor. We smell odors. And seems like somebody say, oh, we could smell something that smells bad. It's just odors. See, what smells bad to you may not smell bad to me. Because some of you probably had on some cologne somewhere, and somebody said, what does that smell? Because they didn't like the smell. To them, it was probably odorous or stink, but it's odors that we smell. What do we see? What do we see? We see light. We see light. We see light. What it is the object gives off a certain amount of light, and that is what we see. We see light. Okay? Now, did we talk about taste? What do we taste?
We taste things that we put in our mouth.
We taste 4, but how do they taste? We taste 4 different things. We taste 4 different things. That's right, sweet.
Spicy.
No, we don't taste spicy. I'll tell you about spicy in a minute. We taste sweet. We taste sour. We taste salty.
Cold.
And bitter. Those are the 4 things that we taste. Now, spicy is how does spicy is sort of like spicy would come under touch. Spicy come under touch because how do you know something is spicy? It does what to your mouth? It burns. It burns. Now, what do we touch? What do we touch? We our sense of touch, sense of feeling, our sense of touch is 2 things that we feel. We feel. It's okay if I erase this stuff, right? So we moving right along. We feel pain, and we feel pressure. Pain and pressure. Pain and pressure. Now, all pain don't hurt. Okay? Pain let us know that all these things let us know that there has been a change in our environment, and that's what we recognize. Now, like take for example, did you know that itching was a form of pain? Itching? No. When the mosquito bite you, to let you know that he has been there, that area begins to do what? Itch. But the itch don't really I don't want you to be under the impression that all pain hurt, because all pain doesn't hurt. It just lets you know that there has been what? A change in your environment. Okay, so those are things that we observe. Let's look at this other one that you use a lot of as you approach your scientific method. Another one that we do a lot of is we like to what? We measure stuff. We like to measure stuff. Now, there are, just so we can move this along, there are 6 things that we measure. There are 6 things that we measure. There are 6 things that we measure. Can anybody tell me something that you measure? What? Okay, you measure, we're gonna call, what's your name? Cordell says that we measure the width of something. But I want to give you one word that'll cover all of, before you tell me width and height and stuff like that. I want to give you one word. Now, if I measure from here to there, what did I measure? If I measure from here to there, what did I measure? The height. Okay, if I measure from here to there, what did I measure? Huh? It's still the height, because we measure from here to there, we said, well, the height. Some people say if we measure from there to there, it will be the width. But I'm gonna give you one word that you can use for that, and we're gonna call it length. Because length is from where? From here to there. That takes care of length. When we talk about traveling from Tampa to Miami, we say it's distance. But what does distance become? Length, because it's from what? From here to there. So when we say one of the things that we measure, somebody, we're going to call it what? Length. Length. What else do we measure? What else do we measure?
How wide it is?
No, we just took width and all of that in the length. What else do we measure? When I came here this morning, and when you came in this morning, they measured something about you. Temperature. We measure temperature. We measure temperature. All right, measure up here so we know what we're talking about. And we measure temperature. What else do we measure? What else do we measure? Some of y'all trying to figure out how long we're going to be in here. What would you be measuring? Time. We measure time. We measure time. And just so we can speed this up, another thing that we measure is volume. And we measure mass. Mass. Now, when we talk about mass, your mass is constant. Your mass is constant. The mass is how much matter is in an object. Now, weight is different from mass, because here on the earth, my weight is 239. What would it be on the moon? It'll be less than that on the moon, but my mass would be what? The same. Okay, so they're not synonymous, but see, weight is the effect of gravity on an object. You're going to see that on somebody's test somewhere in the near future. I don't know whether you take one of those tests at the end of the year to find out if you have assimilated or learned everything that you need to learn. But at the end of the year, you'll find it. And the last thing is density. We measure density. We measure density. And density is a relationship. It's a relationship between mass and volume. So those are the 6 things that we measure. Now, when we take these science skills, that we've talked about, and we utilize them, and we looked and saw how we do observations. We've looked at the things that we measure, which brings us that we're going to take all of this stuff and utilize it in what we call the scientific method. Now, before we get into the scientific method, I have a little video that I want you to see. And then after the video, we'll talk about the steps of the scientific method, and then I can go home. What? Okay. The scientific method is going to be a tool that you're going to be utilizing as long as you are in science. But it's the scientific method. I noticed that somebody mentioned, say, the scientific method, the 8 steps to the scientific method. I don't want you to get caught up in that. I don't want you to get caught up into 8 steps of the scientific method, and because I might have missed a step or something like that, my material is not wrong. I'm gonna show you an approach to it so that it's gonna be logical and sensible, that you won't ever have a problem with it. Okay? All right. I'll wait. While we're waiting on the video, what did I tell you was the way that you learn most of what you know? What's the greatest skill a scientist can have? Observation. And then after you observe something, what's the first thing you do after you observe something you want to know more about it? No, don't use none of the words I ain't used yet. Huh? But what is after I looked at something, after I have observed something, before I do anything, what's the first thing? Okay, let me put it like this. I looked at grass. What's the first thing, when I looked at the grass, what's the first thing I do if I want to know more about the grass? I observe it. I saw it. What's the first thing I'm gonna do if I want to learn more about it? I ain't got no research. Hold on, research before I read it. The first thing I'm gonna do is I'm gonna do like this now. I'm gonna ask a question. That's how I have learned. That's how I've learned everything that I know about. When I saw something different, the first thing I did was do what? I ask a question. Now somebody, when they tell you that you ask a question, they tell you this, with this new technology that we have, what they tell you? Google it. Research. See, Google it has become the new word for research. Now you could Google it, you could Bing it, you could do whatever you need to do, but the first thing you do after you ask a question, you do some research. Now, after you've done some research, you get an idea. You have an idea, right? And that idea that you want to share with somebody, you might call it your what? Now we can use some of the wonderful words. Your hypothesis. Am I making sense so far? Am I making sense? If I ain't making no sense, we wasting time. If you don't understand what we going on, if you didn't ask a question, then we wasting time. Now our hypothesis is a logical explanation as to what I think. And guess what? This is a great word right here, because guess what? Your hypothesis can neither be wrong nor right. The information that I gather, and we'll talk about gathering information in a minute, the information that I gather determines, it either will support my hypothesis or reject my hypothesis. But my hypothesis is what? Neither wrong nor right. The information that I collected will either support it or reject it. Now, how do I go about collecting information for my hypothesis? What do I have to do? Experiment. Okay? I ask a question, I do some research, I hypothesize, and then we come with this wonderful thing called experiment. It's 2 steps to the experiment. You have to, 1, design it, And then the part that most of us lack, we have to do the experiment. You design the experiment, then you do the experiment. And the information that you collect is called what? The data. Now, after I collect this data from the experiment, we got 1, 2, 3, 4 steps so far, right? Yes. Okay, after I collect this data, what do I have to do? You analyze. I have to analyze it. I have to analyze it. And after I analyze it, and let's see, you understand what analyze means? I look at it and see what the data says. That's all I do. I just look at it and see what the data says. And then after I analyze the data, what do I have? What's the thing before the last thing that I do? I draw a conclusion. I draw a conclusion. And then what do I do after I draw a conclusion? I share it. I share my results. You can call it communicate your results or share your results. Share. Now let me see, we got 8 things. 1, 2, 3, 4, 5, 6, 7. We only got 7. We only got 7. So when I share it, what do I have to do again? What do I have to do? I have to do it again. I have to do it again. No, we got 8. Do the experiment again. You have to do it, we said, and even doing this experiment, you have to do it more than, you have to do it at least 3 times, because if you do it just one time, you're just doing a trial. You have to do it at least, you have to do it at least 3 times. You have to do it at least 3 times, because if you do it just one time, you're doing a trial. Okay? Yes. So now, I like this way. You got your 8 steps. It's 8 steps up here. 1, 2, 3, 4, 5, 6, 7, and do it again, make 8. But the way we did it, I ain't got to worry about trying to figure out what I'm supposed to do next. The logical progression. A logical progression, but that's what science is. My favorite science was Spock. Now, you probably don't know Spock, because now I'm telling my age. When Mr. Spock was on Star Trek, and whenever you ask him anything, he was always direct and precise. And so that began to, I just like Spock because he was always accurate. Okay, the video ready? Okay, let's look at this video and to see if what I've told you is the same thing that the video is going to share with you. Let's see the video. Do I need to erase that?
What's all this, Mia?
Don't touch, Sam! That's part of my experiment!
Experiment? What are you, a scientist now?
I am using the scientific method to see whether or not hummingbirds are attracted to the color red.
Can't you just...
Everybody in the room, if you want to hear the video, you have to turn your headphones.
keep track of which bird feeder they eat from the most?
That is kind of what I'm doing. By going through each step of the scientific method, I can test my theory to see if it's true or false. The scientific method is the process that scientists use to investigate the world. I had put a red feeder and a blue feeder up in the tree, and after watching for a few days, I observed that most of the food was gone in the red one. That's the first step of the scientific method. Observation.
Well, doesn't that observation mean that hummingbirds like the red feeder better?
It could mean that. Once scientists make their observations, they start to ask questions about what they've seen. Like, why was the food in the red feeder gone first? Then they come up with a hypothesis that might answer their question.
Who?
Hypothesis. That's science lingo for prediction or a temporary answer that you can test. My hypothesis is hummingbirds are attracted to the color red.
So how do you test if your hypothesis is correct?
That's the next step, designing experiments. An experiment is a scientific test to try out a theory or to see some effect. To test if hummingbirds really are attracted to the color red, I hung up 4 different colored bird feeders with exactly the same amount and type of food. When scientists design an experiment, they try to control every little variable, things that might affect the outcome.
That's why you told me not to touch. You were worried I'd disturb the variables.
If you don't control the variables, it's not a fair test. If you touch one of the feeders, the birds might not eat from it because you touched or spilled it, not because it isn't red.
Sounds a little nitpicky, Mia.
Scientists can never be too careful. It's also important to write down every step in the experiment. That way, you can do it over to compare your results.
Is that what's in that notebook?
Yep, but it's also where the next step of the scientific method comes into play. Gathering data.
Data is information, right?
Right. I took a picture of each bird feeder every morning and night for a week. I pasted the pictures in this notebook and labeled the time and date and wrote down which feeder had the most food missing each day.
Why'd you do it for a whole week?
To make sure the results were the same every time.
Were they?
Let's draw our conclusion and find out. Drawing a conclusion is like the aha moment. It's when you look at your data to see what it tells you.
Let's see those pictures you've got. That's your data, right?
Yeah, I've carefully organized the pictures into a chart to show my results. We need to ask, does our conclusion fit our hypothesis? Our data shows us that they ate the food in the red feeder the most. Our conclusion supports our hypothesis. Hummingbirds are attracted to the color red.
But why are they attracted to the color red?
Why is the final step in the scientific method. Keep asking questions.
I guess that's why scientists keep on finding out more about the world. They watch the world around them, develop hypotheses about how things work, and test their hypotheses with cool experiments. Once the experiment is done and the data is collected, scientists can draw conclusions about their hypothesis and find out if they were right or wrong.
Right. Observations, hypothesis, experiment, data, conclusion. That's the scientific method behind the madness.
Okay. Any questions? Before, any questions? Now you can also, those of you that video that you just saw, I can share it with you. There's a website that's free. It's one of my favorite websites because we helped develop it. And one of my favorite websites, it talks about things on and I don't really deal with grade levels because that scientific method is the same one that you will use when you're in college. The periodic table that you're going to be introduced to later on in this year, the periodic table is going to be the same periodic table that if you're sitting in high school or if you're sitting in a classroom in college, that first column will still be lithium, sodium, potassium, rubidium, cesium, and francium. I don't care where you go, it's going to be the same. So if you learn it now and utilize it now, you don't have a problem. But before I leave you, and I'm just about ready to go, there is a thing that one of the ways that we illustrate our data, and somebody, your science teacher, when they get back with you, they're going to talk to you about experiment, and they're going to talk to you about variable. But I just want to leave you with this little word, these 2 words here, dry mix. And everybody here familiar with graphs? How you graph stuff? Okay, now it's a certain way so that we can pass this information on to somebody else, because one of the things we share information, some other scientists will look at our experiment and they'll try to duplicate our experiment to see if the results that we got was accurate when we make our publication, right? Yes. So one of the things that this dry mix, it says the dependent is, you have 2 kinds of variables. Your science teacher share those with you. You have 2 kinds of variables. You have a dependent variable or responding variable, and you have an independent. So this is your y-axis right there, right? And that's your x-axis. Whatever you plot, mix the manipulated or the independent variable goes on the x-axis. So that's how you say if you got y, got x, where they intersect, that's the first point on your graph. I think that's all for me today. That's all for me today, unless you have some questions about anything. Oh, I forgot to tell you this thing. See, that little video that you saw, some of you look like scientists. Well, anyway, everybody in here is scientists, because everybody in here been asking questions since they was born, right? Why grass green, why sky blue? You've been asking questions all your life, so you've been a scientist. So that little thing that we just looked at, that I was about to tell you about, it's called Study Jams. And it's my kind of website because it's free. I ain't got to pay nothing for it. I just can go into it and look at Study Jam, and they have some materials there for science and math. And in your spare time, you can work on some things to enhance your intellectual aptitude. Okay? If there are no questions? Yes, ma'am.
Could you show us an example of how they should be writing out the hypothesis? I think that's where they get stuck at with questions, and then how to write out. You know, they come up with their observation, all right? And now they have to get with the learn how to write out the hypothesis.
They
get confused on how to write the hypothesis.
we like this. We like, for the hypothesis, we like a if, then situation. If I do this, then this will happen. Okay? If then.
I have a question.
That's as simple as it can get. If, see, like take for example. Now, I live in this neighborhood, and I got this long-haired Chihuahua. Okay? She thinks she's a Rottweiler, but she's just a long-haired. She's just a little thing. Okay? She barks at everything except me. Except when I'm leaving, if I'm not taking her with me, then she'll bark at me, like she's trying to tell me she wants to go. All right? Now I talk to her in English. I talk to her in English because that's the primary language that I speak. And when I tell her to come, she comes. And when I tell her to sit, she sits. Now, my neighbor down the street, she has a Chihuahua also, but hers is a short-haired Chihuahua. And she talks to her dog in Spanish because that's her primary language. When she tells the dog to levántese, the dog just get up. And when she tells the dog ven acá, the dog come running to her. Now, you probably say, now that's just an observation. I know that. Now, but you know my question is, I talk to my dog in English, and she talked to her dog in Spanish. I'm kind of trying to figure out that if these two dogs got together, would they have a problem communicating with each other? Or are they bilingual? Do they speak Spanish and dog and English and dog? Would they have a problem communicating? Make sense? You know, scientists think of dumb stuff like, you know, scientists think of stuff that don't nobody else think of. So what do? If I speak English to my dog, then would he respond to Spanish? And somebody already said no. Somebody already said no. You don't know because you ain't did the experiment yet. I understand everything you're about to say, and that's what we're talking about. That's what we're talking about. But in order to verify the information, we have to do what? An experiment. Okay? Yes, sir.
The people come on, around my house, the people, dog, they understand English and Spanish.
Okay. Okay, so you understand how the experiment can go. And you're just trying to find out some information. And if at the end of this experiment, whatever I find out, it don't make my hypothesis wrong or right. It's the data that I collected that did not support my hypothesis. Okay? It's okay. And don't you, when you're doing the experiment, don't make up stuff. Don't make up stuff.
Because they might want to make it right.
Yeah, ain't no such animal. Like, take for example, I got one little experiment for you that I got some marigolds. I got some marigolds, them little yellow flowers that you have in the back here that you grow. And I'm trying to figure out what they grow best in. Do they grow best in black dirt, or do they grow best in sand, or do they grow best in if I take a mixture of the black dirt and the white sand? Now my hypothesis is if I plant marigolds in black dirt, if I plant marigolds in black dirt, then they will grow better. Now, one day we're going to talk about how you write these up really, really good, because you don't want it to grow better. Because what's better to you is not better than me. We need to have a what? A measurable thing. So instead of saying grow better, we're going to say what? Faster. Faster will work. Faster will work because we can time it. Yes. We can time it. We can measure that. I can't measure better. I can measure time. And another thing about the marigold I can measure is to see if they're growing better is what else can I measure? Height. And so they will grow taller. Okay? You understand? Okay, so this science thing, this is the easiest, most important class you can take because you get to get your hands in it. See, today is the longest lesson that we will possibly have when it comes to science. The rest of the time, we'll experiment and mix up some stuff and see how it works so that you can be interested in it. That's the thing that when Solomon talked about nobody wanted to lead the class, we was always doing something. I got an experiment that maybe one day we can do. It's called, anybody familiar with dishwashing liquid? Dishwashing liquid, stuff you wash the dishes with? Now, have you ever asked yourself, when you're in the store, which one of these dishwashing liquids cleans better? No. Well, let's say we got to find a way to determine. Let's ask the question, which one of these dishwashing liquids will make the biggest bubble? That might give us an idea of whether it's got more cleaning power because it makes the biggest bubble, right? I got this wonderful experiment for you that you can take. We get some glycerin and we get somebody holler at Dawn because somebody like Dawn. Somebody in here like palmolive. Anybody like palmolive? Anybody like palmolive? Is it? And another one, no, Gain. what we're gonna do to make sure that we don't have a whole lot of stuff that's missing, we're gonna get all the clear ones. Dawn is blue and clear. Palmolive is green and clear. And somebody said gain. Gain is sort of like yellowish and clear. Okay? Now, we're gonna make a 1, then I'm going home now. 1, the 6 to 1 solution. We're gonna have 1 part of it is gonna be dishwashing liquid, 6 parts of it will be water, and 1 part will be glycerin. Glycerin. Because glycerin helps the grease to slide off the plate good. So we're gonna add it to that. But we're gonna all of them are going to be clear liquids. Now, you know, they have some in the stove, dishwashing liquid stuff that you can't see through. You know, like that pink, like when Dixie got some pink that look like soap. We ain't gonna do that. We're gonna get the clear ones. And then what we're gonna do is we're gonna mix them up, 1 to 6 to 1. And then on a nice table, we're gonna put some bubbles on the table, and with a straw, we're gonna blow it. And then we're gonna blow the biggest bubble that we can blow. And then we're gonna measure the diameter of the circle and determine which one make the biggest bubble. Your hypothesis is, if I use Dawn, then it will make the bigger bubble. That's the hypothesis. Okay, that's it. Now what you do is with those other 3 that you have, you just take and do the experiment. And then you write down the data. Then you analyze, you measure the bubble. Then you analyze the data. After you analyze the data, you do what? You draw a conclusion. And after you draw your conclusion, you share your results. Scientific method. Okay? If there are no other questions, it's time for me to go home and get ready to look at Young and the Restless. Any other questions? Any questions? No. Okay. All right. So thank you for coming. Thank you.